Okay, we're going to discuss host-based intrusion detection systems and other tools for determining changes in critical systems files. Network intrusion systems were used to determine if there were any packets coming in or out of the network that were not what they should be. So it concerned both ingress packets and egressing packets. And what we really concentrated on was looking at signatures that were matched in against all the packets that were coming in to determine if there was something that was going awry with the packets traversing the network. With host-based intrusion detection systems, now we're no longer talking about the network, but we're talking about individual hosts. And in particular, we're talking about looking for signs that somebody has actually gone in and was able to break into the computer and then try to change or manipulate the files in the file system so that it would cause a problem, for example, a denial of service attack, or whether they installed a Trojan horse or done something nefarious that they should not be doing. And recall that when we're looking at the security of a system, there's different aspects of information involved with the network and the host that we can use to determine whether there has been a possible intrusion or an attack on our network. And so that includes looking at things such as the firewall logs, and the intrusion detection logs, suspicious users, and such things as just simple old logging, for example, logging of the processes or logging of other things going on that are written to the syslog program if we're talking about Linux, to determine whether things are okay. So the first thing we need to do is to set up our system so that they detect changes or detect things that are occurring, activities that should not be occurring. For example, are there things coming in, being shown up in the firewall logs that should not be occurring? Intrusion detection systems can tell us whether somebody is trying to break into a system, or if they have broken into a system, what they've done. Whether they're suspicious users logging in. For example, if Ted or Mary always work from home, or always work in the office, but somehow now they are logging in from an IP address that's not local, they've logged in from an external account, that might be an indication that somebody has taken over that account. And then once we detect these anomalies, we can compare that to a checklist of things that are either good or bad that should be occurring or that should not be occurring. And then based upon that, we can send that information to our response team to determine what should be done about the problem. So what are host-based intrusion detection systems? Specifically, they are a program that runs on a single specific host, which means that if you've got an organization that has 1,000 computers and you're setting up host-based intrusion detection on each of these, then you would have to have 1,000 different programs running, one on each of the individual hosts. And essentially what they do, the host-based intrusion detection systems, is to analyze the activity on that host, and generally it's looking at the changes in the files. If you think about that for a second, there's some files on our computers that should not be changing. They should not be changing on a regular basis. For example, those that are involved with file and disk administration, those involving the kernel, and so on. Now, there's going to be other files that also change, such as those involved with work products that will be changing on a daily basis. We expect some of those files to change, those that are involved with work products, but those involved with the operating system, we don't expect to be changing unless there's a specific purpose for them changing, such as an upgrade or an update of those files. So we want to look at certain things such as systems calls and look at the file systems modifications that are making these systems calls. Why did a particular file change at a particular point in time? If we don't know why that changed, then that should be cause for concern. We also should be concerned with memory integrity, in that the memory is vulnerable to attack since those programs are a part of the monitored system. And there's really no protection against DOS, denial of service attacks, if somebody is able to get onto the system and unauthorized users and change some of those files. Recall that network-based intrusion detection systems are totally different animals. network-based intrusion detection systems analyze network traffic by inspecting the packets. They decode the packets and then compare those packets against, usually for signature-based intrusion detection systems at least, against a series of signatures to determine whether there's something wrong with those packets. Network-based systems are easy in non-switched networks. In switched networks, however, boink, boink, there we go. We need a network tap or a port mirror if we're running a switched network, because that's the only way we can listen across all the different ports that are going in and out of our domain. And or we can only monitor the traffic in very specific segments, such as the traffic via the gateway. However, recall that network-based systems can become bottlenecks in high-speed networks because each packet must be decoded. Each packet must then be compared against all the different signatures in the database to determine if there's a match between those two. Also realize that you cannot analyze encrypted packets. So if somebody has an end-to-end VPN from somewhere directly to their computer at work, there's no way that we can decrypt those packets in order to analyze those. So there's a limitation there for network-based intrusion detection systems. Okay, we can also combine these, and I'm only going to talk about this briefly, is hybrid intrusion detection systems, which combine the host-based and the network-based intrusion detection system. And then each subsystem, the host-based and the network-based, would report to a central authority system that's actually overseeing both types of intrusion detection systems. That's all I'm going to say about that. Okay, modes of operation of intrusion detection systems. There are 3 different modes of operation, one of which is only involved with host-based intrusion detection systems. That is integrity checking. Is you're checking the integrity of a file. That is, has this file changed from time A to time B? And can we determine why that change occurred? With respect to network-based intrusion detection systems, recall that we can look at signature recognition, and I've just spoken about that, so I won't beat a dead horse, or anomaly detection. And if you recall what that is that requires looking at network traffic over a specific period of time and determining what is normal traffic, and using that as a profile, which then you can later compare to at different times to compare packets crossing the network to this profile to determine if anything looks out of bounds. So for host-based intrusion detection systems, typically use checksums, that is hash values or cryptographic signatures, to verify the integrity of the files on your hard drive. Some systems actually allow you to verify binaries before they execute to determine whether that's the original binary that was installed in the program on your hard drive. Or you can even verify binaries before granting network access, such as some personal firewalls do this. And you can also use this to verify integrity of important data structures as well, such as the Windows registry. So now let's start thinking about an attacker. Is that we want to get on, we want to break into somebody's computer. What kinds of things could they do to hide the fact that that intrusion has occurred should a host-based intrusion detection system exist on the host? Well, one thing we could do is we could tamper with the database of hashes. If we could tamper with that database, we could upload a program, let's say a rootkit that has several different programs that hide the fact that an intrusion has occurred, and then update that database to reflect the new hashes of those programs that were installed by the intruder. We could also attack the cryptographic method directly, but that's something that is very difficult to do, and that's not something that most hackers would want to try to get involved with, because it's extremely difficult for most of the hashes that are used for intrusion detection systems. Something we'll talk about a little later after host-based intrusion detection systems are prevention systems. Let's spell that, prevention. Intrusion prevention systems. And what these are is they're automated reactions to alarms from the intrusion detection systems, such as updating a firewall blacklist, or using honeypots, and I'll spend a whole lecture on honeypots a little later, and also something called tar pits, and we'll touch on that a little later. But just realize that there's both intrusion detection systems, which would detect a problem but don't actually deal with it. They just monitor the system and then alert a system administrator, or you can have a system that actually attempts to prevent an intrusion. Okay, to delve, we talked just a little bit about cryptographic checksums. We see and use these all the time, whether we know it or not. On suspected intrusions, the integrity of the files must be assessed. And by integrity, I mean whether the file has changed or not. So essentially what's done with a host-based system is to check the current file's checksum against the evidence of a known good system. So essentially what we're going to do is we're going to create a database of checksums for a known good file system. So we're going to create hashes, MD5 or SHA-1 hashes, or other types of hashes for each of the known systems, and then we're going to try to protect that database so that it can't be corrupted or changed in any way by an intruder. At a later time, what we can do is then we can unencrypt that database and then go through and have a program automatically create checksums for the existing files on the hard drive and compare those against the database. If those do not match, there's a reason for that, is that something has changed on the hard drive. So one of the most often used checksums is the Message Digest 5 algorithm. It's a hash or checksum or a cryptographic one-way hash. It's 128-bit in size, so it's a very, very large number. And there's implementations for Windows as well as for Unix. For any of those who've used Linux or any version of Unix, you know that there's something called MD5 sum. For let me update this in real time. Linux is called MD5 sum. For the BSDs, it's called MD5. And those are the executable programs, MD5 sum for Linux and BSDs, MD5. And they do exactly the same thing. They create the 128-bit checksum that's based upon the contents of each file. So this is just a simple example illustrating how to run MD5 sum. Here we're running it against this firewall script. We typed MD5 sum and we see we get the 128-bit number right here. And of course this number is uniquely correlated with the contents of this file. If we go through here and change one bit of information in this file, we get an entirely different MD5 sum. For Windows, there's lots of different programs. There's one called MD5 Summer, which is what this one is, and it's really neat. It's just drag and drop. I think this one's a drag and drop. Maybe not. I can't remember. There's several of these. But what this does is it shows you it's actually calculating the MD5 sum here, and it tells you whether a file is unprocessed, whether it's processing, or whether it's okay. If there's an error, that is, if there's not a match between a calculated MD5 and the MD5 of the file that's being processed, that means that the file has changed. And you know, with Linux and Unix and any file that you download, regardless of the operating system, you'll find that a lot of people will actually calculate that MD5 sum for you, like this. This is from, I forgot where this is from. I think it's from DistroWatch. And so what this allows you to do is that when you're downloading these ISOs, is to make sure that that something hasn't happened in the download process, is that you take this downloaded ISO, you run the MD5 against it and compare it to this. If this does not match the calculated MD5, what has occurred? Well, for one thing, we know that the integrity has not been verified, so there's something different about the contents of this file and the one that was originally calculated right here. What is the difference? Well, we don't know. We just know that there's a difference. What might a hacker try to do in this instance to try to subvert the integrity check process? Let's say instead of an ISO, this was a program that's downloaded to do something on your computer. Well, what the hacker could do is to break in and to upload their own version of this program that has a backdoor to it, and then some way to take this HTML file and change it so it reflects the modified version of it right here, which means that you would essentially be downloading a file that was Trojaned right here and installing it, but it would still check the checksum right here, even though this file is has been modified in some way. And so let's go back here quickly. Notice here what I've gone in, I've just changed a single character in this file. I've now run the MD5 sum hash right here. Notice this MD5 sum starts with a 78FF. If we go back up here, we see it's been changed. That's been changed. And all it took was the addition or the modification of a single character within this file. Does it tell you what changed? No, it only tells you the fact that it has changed somehow. For some strange reason, I should probably know this, when you're running an MD5 checksum on a binary file in Windows, you must use the -B flag in order for it to work correctly. Otherwise, it gives you a checksum which does not reflect the actual pure contents of the file, but this is unnecessary with Unix, so just remember that if you're ever checking using an MD5 checksum on a Windows files. So there's a lot of files on your hard drive, and if you're running, let's say, a checksum program, you want to make sure that it does a thorough job of it and automates as much of the process as possible. This is just a simple illustration of how you can do this on a single directory. If you want to check the checksums of a single directory, here we go. We're looking at the files here in this directory, and where are we? And so this gets us, this is really weird. I took this as an example from a book, but you don't necessarily have to do it this way. If you just typed MD5 sum star greater than list.md5, it's going to give you this information. But what this has done is it's calculated all the MD5 hashes of the files in this directory. And then if you want to go back and check the status of these, whether they've been changed or not, you type MD5 sum-C, which is check for all the files listed in here. Notice that it says that everything's okay. Nothing has been changed since this file was originally created. However, if you do go back and you change a couple of files, it does indicate that what files have changed. It doesn't say how they've been changed, just the fact that the integrity check has failed. Okay, automated tools. There's several free and commercial off-the-shelf tools for integrity checking. One of the most popular of which was Tripwire, which was created at Purdue by Gene Spafford and Gene Kim, one of his students. And there's also one called AIDE, the Advanced Intrusion Detection Environment. And there's one called Samhain, S-A-M-H-A-I-N. Let me write that in here. And I've used all three. Well, excuse me, I've played around with AIDE and Samhain, and they work quite well, but I'm more used to running Tripwire. This is now a commercial product, and they do have a version for Unix that is free and for Windows that is free, but their commercial off-the-shelf is a much more expanded version, and it's got a centralized authority that can be used to monitor a series or a set of hosts. The free version is does not do that, and this can be found at tripwire.sourceforge.net. Here we go. It's amazing what you remember when you start talking. Okay, each of these tools automates the process. Now, AIDE and Samhain is only available for Linux and Unix, and Tripwire is available for Linux, Unix, and Windows. These are free, open source, free open source. This has two versions: an open source free version and a version that is commercial and off the shelf. So each tool automates the process of checking the integrity of files, And essentially they all do the same thing. They create a list of checksums based on a configuration file. You can specify different hash functions to use, as we see right here. Certainly we don't want to use anything that's as small as CRC32. There's a possibility of collisions. So I would strongly suggest that you at least use an SHA or MD5 cryptographic hashes for this. And also what these do is to make sure that no one changes the database and the policy files, is that these are cryptographically signed with cryptographic keys so that an intruder can't change this information. This just gives you a little more information on Tripwire if you want to read some more information on it. And also, if you download the Red Hat 9 manual, actually there's manuals, it does a great job of explaining how to install and run Tripwire 2. So if you go to the Red Hat site or just search for Red Hat 9 manuals and Tripwire, you'll see it's got a PDF file that's really nice. Explains everything. Okay, so essentially what I did in another class is to actually run through how you would go about downloading and installing and configuring and running Tripwire. And this is just one of these you see on the www.slated.org site. Is Tripwire for Fedora Core 5. You can see there's different versions of it. There's a source if you want to build this on your own. There's one for 32-bit i386 computers and one for 64-bit computers. These are the hashes right here of the files. So you can determine the integrity of these files. And here's and this is something you saw before. If you look at the introduction to cryptography, it actually explained how to use this. To actually look at the digital signatures, look at of this file to determine whether this file had been changed or not. So in order to understand all this, you need to make sure you go back and view all those iClass files. So Tripwire, again, protects itself using the LGAML 1024-bit asymmetric cryptography. You can use 4-message digest algorithms to ensure data integrity, including MD5, Havel, SHA, SHA. You surely wouldn't want to use SHA, SHA1, because there's a problem with that, with SHA. Secure hash algorithm 1, or CRC32, which you do not want to use. It also uses authentication and encryption between the manager and the server. This is for the commercial version, and you won't even see anything about this in the freeware version. So the process of running Tripwire is to install it, as you'll see in the running Tripwire iClass. And then you want to look at the configuration files and the policy files to determine if you need any changes in there. And then you initialize your Tripwire database, which simply creates checksums for all the relevant files that are indicated in your policy file. Then you cryptographically sign the database to ensure that an intruder can't get in and change those files. And then you put a cron job in your hourly, daily, or weekly. Good gosh, you don't do it hourly, but you might want to do it daily or weekly so that Tripwire runs by itself in the background, because it is very intensive creating those MD5 files. And this is just a little script you can put in your cron job that runs the Tripwire check, and that's a dash in here. So user sbin Tripwire dash check, and you'll see all that done in the running Tripwire iClass. Here's your Tripwire policy database, and it indicates all the things about your security policy that you want implemented in Tripwire, and it's explained much more in depth in the running Tripwire iClass. But this is what it looks like, and it's looked like this forever. Okay, we kind of made a big jump there. So make sure that you look at your the running Tripwire iClass, and what you'll want to do is, and I indicated such in the iClass, is that you want to download and install, or if you've already got it on your computer, is actually run Tripwire to see how it works, to play around with some things just to see if you can catch some of the changes. Okay, LogWatch is another program that comes with SUSE, Fedora, and Red Hat, and what it does is is it's a program that's automated that looks through your logs and determines if there's something that's of a negative of evidence of an intrusion in your logs. And so again, this is an automated check of things that are going on with your system. And essentially what it does is you set this up as a cron job, and you run it, let's say at night. It looks at all the logs, and then it matches the contents of your logs against the database to determine if there's something in those logs that you should be noted. Here we see that there's an active system attack, and it tells you when this was created. And so LogWatch is from Psionic, which is no longer in existence. It was bought by Cisco, but it still comes with, you can still download it and install it. There's also one called Swatch, which is like the grandfather of all LogWatch programs. And I've run it a couple of times, but I had a little difficulty getting it installed, which will happen to run, because there's also some Perl scripts that you have to download and install as well in order for Swatch to work. And so you can put a cron job in to check your logs, from 1 minute, 1 day, whatever. I had mine at one time running every hour, and you can't imagine all the emails that you get from LogWatch. That would be 24, and that's just a lot of information to try to process, every hour. And this is just some of the indications from LogWatch. This is it says an active system attack. It says that it found attack alert TCP send normal scan, so somebody's scanning my system. This was noted by Port Sentry, which is like a dynamic firewall utility, which was also bought from Psionic by Cisco. Then you have some security violations that LogWatch caught here. Notice that it said it's authentication failure. Someone was trying to log in right here and unsuccessfully logged in. Here's JPC, which was me. I logged in as root. JPC logged in as root. So I set this up to indicate whether if anybody who was a normal user tried to log in as root, whether they did it successfully or not, and LogWatch caught those. And this is just how it looks in an email. So what the LogWatch email alert looks like. In our Linux course, and briefly in the computer network security course, we talk about the syslog daemon. And the syslog daemon is a Unix daemon that controls the logging of various events and activities on your computer. And Windows has the same kind of thing. It has 3 different sets of log files that it uses and creates. And so you've got the same kind of thing for Windows. Getting back to syslog, note that any program can generate a log file, and what you can do is set it up so that the syslog daemon captures those logs and places those in the syslog. If you're running Linux, you should always have this started. Notice that it's you start this by going to the init.d and using this script syslogd to start it, or you can have it run automatically by putting it in a particular directory. So, and you can control what gets logged, and where it's logged to is controlled in the syslog.conf file, which is located in the etc directory. So if you've got your Linux up and running, why don't you go to the etc directory and take a look at syslog.conf, because we'll talk about the contents of that in a moment. And so you find that a lot of these messages that are created, a lot of the logs that are created by these programs are spit out to the verilog messages file, which we looked at extensively in several of the other courses. However, you can separate what puts out to what log according to any criteria. So some of the facilities that are included in syslog are the auth, cron, user, and mail. So anything involving logs, authentication activity, or messages associated with a cron and at. Any message generated by a user program or messages related to an electronic mail can be written to your messages file. And then, so not only do you have facilities and activities, but you also have levels of activity. For example, the emerge stands for emergency. The system is unusable. Critical precludes functionality of a component of a utility or subsystem. A warning message, or just normal conditions that may or may not have significance. And this is what it looks like in here. So if you have for any of these facilities, you can have info, cron, author privilege, anything in here. It says don't log private authentication messages, of course, but anything else will be written to verilog messages. Anything with authorizations, authentications to the system is going to be written to the secure log. Anything having to do with mail, whether it's emergency, critical, warning, and so on, we've written to the mail log. Anything that has to do with cron, whether emergency, critical, warning, or notice, will be written to the cron log here. Okay, when you view the syslog comp file, it will show an entry that has a kern that is commented out. If you want to look at the kernel messages that are occurring, you can uncomment this entry, and then that will be written to the console, or you can have it written to the messages file. But just realize anytime there's anything having to do with the kernel, that it would be written to the messages file, unless you just indicated that you wanted something at the emergency or critical level. And just looking in here, this is the log file. This is the messages file, so it indicates when the system restarted, when Tripwire did integrity check. So here's some of the kernel messages down here. The disk is absent for floppy 0, our floppy drive, when the system was last shut down, and so on. Okay, real-time human logging. Well, this is nigh on impossible because there's a lot of messages that are being written out to the system, and the system administrator has a lot of things to do rather than just sit there and watch the logs running across the screen. Log watchers, however, aren't as good as a human in catching problems as they occur. What you can do is you can tail the log file, so you can view the log files as the entries are appended to the end, or you can use a good program called Xtail, which is available for Linux and free, to display all the appendices to all the log files in a directory. So essentially what you've got running is that you've got running, okay, and let's tail verilog messages. There we go. So you could have a terminal set up and running right here, and then anytime anything is written to the messages file, that actually will show up here. So it's a first in, first out. It's a FIFO. And so as soon as, for example, something is written, this will disappear from the screen, and the new one will appear down here. So if you're interested in spending your time looking at what's going on in your messages file, you can tail your log files. And so this is the Xtail program. And so what this is doing is I'm running Xtail, and I'm looking at all the logs that are changing in the verilog directory. So here we see that something changed, was added to the end of the secure log. Opened a terminal window, and here's one that was changed in the messages, and all these were involved in actually what was occurring right here. Okay, that ends this class on host-based intrusion detection systems. The next thing we'll talk about will be honeypots. And so I would make sure you get in here and you try all these different, looking at syslog, changing some things in the syslog.conf file, log in, log out, do some things on your computer and see how the messages file, the secure file, all the other logs are updated. Also, as you'll see in the class running Tripwire, is that I want you to start playing around with that. You can play around with Tripwire, which is very easy to use. You can just follow along with what I did in the running Tripwire I class, or you can download AIDE or Samhain and try those out as well. But you need to get used to working with these programs because they will be your friend as a systems administrator.